So today's lesson was 3.4, and it was all about the quadratic formula. So this is actually the lesson title right here. So the quadratic formula is a method that can be used to solve any quadratic equation. And in order to use this formula, you just need two things. You need your equation in standard form, and you need to have it set equal to 0. So those are only two things that you need, and then once you have that, you can simply use this formula, plug in your a, b, and c values, simplify, and get the solution to the quadratic equation. So very quickly, just remember, the methods for solving quadratic equations, that we have learned so far are graphing, where you want to identify the x-intercepts, and those are your solutions. The second was using square roots, or that was just isolating the variable x. The third method was factoring. We also learned completing the square, but completing the square is also considered using square roots. And then the last method today that we are learning is the quadratic formula. So these are the methods we have at our disposal at the moment. Or actually, we will have after this lesson. Alrighty, so let's jump right into it. If I want to solve this equation using the quadratic formula, I have to start by putting it in standard form and having it set equal to 0. So I have to move this 5 to the other side. So that would give us x squared plus 3x minus 5 equals 0. Now, if you think you're going to make mistakes with plugging into the formula, I would recommend writing out what your a, b, and c values are before you plug into the formula. So a in this case is 1, b is 3, and c is negative 5. I also recommend that you write the formula at the beginning of every problem, because this will help you to memorize it for the test. All right, so plugging into the formula, I would get x is equal to negative 3 plus or minus 3 squared minus 4 times 1 times negative 5 all over 2 times 1. From there, I just want to simplify using PEMDAS. So PEMDAS says to start in the parentheses. In this case, that would mean simplify the part under the radical. So when I square 3, I get 9. 4 and 1 is negative 4. Negative 4 and negative 5 is positive 20 over 2. Combine the parts under the radical and you get 29 over 2. So that is as far as I can go, because there are no perfect squares contained inside of 29, so that's my final answer. Now I do want you to be aware that even though we solved this by using the quadratic formula, we could also have solved it by completing the square. So let's do this problem by completing the square and see that we'll still get the same answer. So remember, to complete the square, I need a perfect square trinomial. So I would do b divided by 2 squared. So 3 divided by 2 squared is going to give me 9/4. So I need to add 9/4 to my equation here, and also subtract 9/4 from my equation. This right here is the perfect square trinomial, which in factored form is x plus 3/2 squared. And I'm going to add 9/4 to the other side. If I want to combine these, I need common denominators. So 5 is the same as 5 over 1. If I multiply the top and bottom of that by 4, I would get 20 over 4. So that's 20 over 4. And then combining that, I would get 29 over 4. Now I know I just did that all in one step, I don't recommend that you do that because it'll lead you to make careless mistakes. So I would recommend showing all that work on your note packet. So at this point, I'm going to square root both sides. That gives me x plus 3/2 equals plus or minus square root of 29. I don't know, but the square root of 4 is 2. Subtract by 3/2 on both sides, and you get x equals negative 3/2 plus or minus the square root of 29 over 2, which is the same thing that we got over here. I just separated the fractions. All right, very good. Let's keep going. Example 2. Solve this equation using the quadratic formula. So same thing as before, I need to move everything to one side. So I'm going to subtract by 12x on both sides and add by 4, which would give us 25x squared minus 20x plus 4 equals 0. Again, let's begin by identifying our a, b, and c values. A is 25, b is negative 20, c is 4. Write the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, and begin plugging in. Now here, our b value is a negative 20, but the formula has a negative in front of the b. So that means we have negative 20 plus or minus the square root of negative 20 squared minus 4 times 25 times 4 all over 2 times 25. Now at this point, I would be looking at these numbers and probably say to myself that the quadratic formula isn't necessarily the most efficient method just because of how big the numbers are. You could still do it, but just something that I notice. All right, that's going to become positive 20. Negative 20 squared is 400. 4 times 25 is negative 100, and then negative 100 times 4 is negative 400. And then 2 times 25 is 50. Combine what's under the radical, and we get the square root of the square root of 0. The square root of 0 is just 0. And 20 plus 0 is just 20, and 20 minus 0 is just 20. So really all I have here is 20 over 50, which is just 2/5. All right. Now, just like I mentioned, we used the quadratic formula for this problem, but we could have used another formula. Take a quick look at this equation and see if you could figure out what other method we could use. Well, if you notice, the first and the last terms are both perfect squares, so this is factorable. So I'm going to solve by factoring. Now, because the first and last terms are both perfect squares, this will factor out into 5x minus 2 times 5x minus 2. If you don't believe me, you can FOIL it and check it. Now that I have it factored, I can set each piece equal to 0 and solve. I'm going to end up getting the same thing in both cases. I add 2, divide by 5, and I get the same thing I did before. I definitely think factoring is easier in this case, but quadratic formula, like I said, will always work. All right, moving on. First, set it equal to 0 by subtracting by 13 on both sides. Here, a is negative 1, b is 4, c is negative 13. Write the formula and plug in. So that's negative 4 plus or minus 4 squared minus 4 times negative 1 times negative 13 all over 2 times negative 1. So that's going to give us negative 4 plus or minus 16. That's going to be positive 4 times a negative 13, which will give us negative 52 over negative 2. 16 minus 52 is going to give us negative 36. Since we have a negative under the radical, we know we'll have I, and the square root of 36 is 6, so we get 6I, and all of that over negative 2. Now, both those values are divisible by 2, so negative 4 divided by negative 2 is just 2, and then 6 divided by 2 is 3I. I don't have to worry so much about the plus or minus because positive 6I divided by negative 2 gives me that negative, and then negative 6I divided by negative 2 gives me that positive. So either way, we get the plus or minus. All right, very good. So that's the solution to the third example. Now, because of the fact that the part under the radical is going to tell us right away, or maybe not right away, but definitely after we simplify the part under the radical, we'll know whether or not we're going to have real solutions or imaginary solutions. In this case, because we had a negative under the radical, we should have known that, okay, we're going to have I in our answer. Because we had a positive value under the radical here, we knew that we were going to get a real solution. Now, that part under the radical, the b squared minus 4ac, because it tells us about our solutions, tells us whether they'll be real or imaginary, this is actually given a name. This part of the quadratic formula is called the discriminant, because if we know the value of the discriminant, whether positive or negative, we can determine what kind of solutions we'll get. And that's what this section of the notes is describing. So anytime the value under the radical is negative, so negative values under the radical, we know that we're going to have two imaginary solutions, and we also know graphically that that means we will have no x-intercepts. If we have a value of 0 under the radical, then, like we saw in this example, because plus or minus 0 is just going to give us the same value, 20 in this case, that will produce only one solution, one real solution, one x-intercept, and that x-intercept will also end up being the vertex of the parabola. Lastly, if you have the part under the radical is a positive value, well, then we just get two real solutions and two x-intercepts, and that's the most common case that we see. Doesn't necessarily mean that those two solutions or those two x-intercepts have to be whole numbers. They could still be fractions and decimals, but they're still real. So in this next example, we're not being asked to go all the way and find the solution to these equations, but we are being asked to find the discriminant and then to use that information to describe the number and the type of solutions that the equation will have. So the discriminant formula is b squared minus 4ac. Here our b value is negative 6, our a value is 1, and our c value is 10. So that means we have 36 minus 40, which is negative 4. Now because our discriminant is negative 4, this means that the equation will have two imaginary solutions and no x-intercepts. So again, this isn't telling us what the solutions are, but it's giving us enough information that we can say there will be no x-intercepts and the two solutions we get will be imaginary. All right, moving on. Again, the formula, b squared minus 4ac. So negative 6 squared minus 4 times 1 times 9. That'll give us 36 minus 36, which is 0. So because the discriminant is 0, this means that the equation will have one real solution and one x-intercept. And hopefully you noticed, hopefully that looked familiar to you. That's a perfect square trinomial. So it could be written as x minus 3 squared equals 0. All right, last one. Again, use the formula. So that means negative 6 squared minus 4 times 1 times 8. So that's 36 minus 32, which is 4, which this means, since the discriminant is positive, the equation will have 2 real solutions and 2 x-intercepts. Very good. All right, last example. On the line below each graph, state whether the discriminant of each quadratic equation is positive, negative, or equal to 0. So look at each graph, and based on the way the parabola is crossing the x-axis, or if it's not crossing the x-axis, determine whether the discriminant would have to be positive, negative, or equal to 0. Then, identify which graph matches the discriminants below. All right, so because there's only one x-intercept for graph 1, I know that my discriminant has to equal 0. In graph 2, there are no x-intercepts, so I know that the discriminant has to be negative. In graphs 3 and 4, there are 2 x-intercepts, so I know that both of these will have positive discriminants. Okay, now in order to do the next part, I need to simplify the discriminant for each of these sections. So this would be 4 minus 8, which is negative 4. So that's a negative discriminant, which means this has to correspond with the second graph. For B, you get 16. That's going to be plus 16 minus 16, so you get 0. So that has to correspond with the first graph. For C, you would get 16 minus 0, which is just 16. So that could be the third or the fourth. So how would you figure it out? Well, one way to do it is to remember that the formula for the discriminant is b squared minus 4ac. So that means our a value is 1, which means there is no reflection taking place. Now, if there's no reflection taking place, it would have to be graph 4. A second thing that you could notice is that C is 0. Now remember, C refers to the y-intercept, which means we have a y-intercept of 0, 0, which also only corresponds to 4. All right. This means that the last option, D, would have to be the third graph, but let's just look at it. 8 squared is 64. 4 times 1 is going to give you 4, and then 4 times 13, I think we said was 52. It's going to be minus 52, so 64 minus 52 is going to give us 12. Okay, again, if you weren't sure, we have an a value of negative 1, which means there is a reflection over the x-axis, which only makes sense here. And that's it. I hope that helped.